And so what I would like to do now is continue this developmental story, and don't be worried here. So what I'm going to try and do is really focus on this question of neuronal identity having been established. How do we now start to innovate the target cells? And we're going to stick with the motor system for a moment and consider the motor neurons that innovate their target muscles. And that's what you're looking at in this image here. And so the job of a motor neuron is to extend an axon out of the central nervous system to find particular target muscles. Not all muscles are the same. Some flex, some extend the limb, find the right muscle targets, and then form a functional synaptic connection. So I just want to give you an indication of those synaptic connections between motor neuron and muscle in action. And so, unbeknownst to you, before this lecture started, I was wired up with electrodes to monitor the state of muscle contraction. So these are surface electrodes which are monitoring the electrical potentials on my biceps and triceps muscle, a process called electromyography. And so what they do is record the ability of motor neurons to activate muscles in a coordinated manner, to flex and extend when Eric is playing tennis, or when you simply take a step, as we'll see in the next lecture. So let's see if we can actually demonstrate nerve-muscle connectivity in action. I hope what you can see is that the amplitude of the discharge here is we're looking at these electrical signals in muscle as I first flex my bicep, triceps, biceps, triceps. This is not just pre-recorded. This is real physiology in action here, because I can alter the rate of these contractions and activations, or I can maintain biceps activation. Probably not for as long as some of you, but at least for a period of time. So here, in this simple demonstration, we can record the endpoint of the developmental program that I'm now going to discuss further with you.